So welcome to the world of acids and bases. We're going to start here by looking at some of the properties of both. We'll look at all the acid properties first, so you want to fill out the left side column of your table first, and then we'll look at bases. Acids and bases have a lot of opposite qualities. So whatever an acid is, a base has the opposite properties. So we'll see some of that as we go here. First off, for acids, acids have a very tart or sour taste. If you eat one of those extremely sour Sour Patch Kids or whatnot, or if you put something sour in your mouth, you can almost feel your salivary glands cramp up. You can feel in the back of your jaw that they have to really squeeze to dilute a lot of the sourness. It depends. Different people react differently to sour foods, but that is definitely something that could happen. Acids are electrolytes. They can be a strong electrolyte or a weak electrolyte. We talked about this during Water World, and that's going to depend, how well they dissociate into water. Because all of our acids and bases are aqueous, meaning dissolved in water. Acids react with indicators, dyes, and we'll see some of these when we do our lab coming up. But for example, pH paper. When pH paper touches an acid, it will have some form of a reddish color, as you can see in that picture. Phenolphthalein is another indicator, and when it's present in an acid, it stays clear. And so there's a picture of a flask that has that going on. That's going to be another indicator that we'll see in lab, so I want to mention it here. Another big quality of acids is that they react with metals to produce hydrogen gas. So like here we see zinc. When zinc metal is placed into hydrochloric acid, well, we start to form some different ions, and also some of the hydrogen ions come together and form hydrogen gas and then bubble out of solution. And hopefully, again, we'll see this when it comes to the lab. Acids are also what we call corrosive, meaning disintegrating. And this is very common with metals, and then also it can be to your skin. There's actually a famous mass murderer in England called the acid bath murderer who disposed of his victims' bodies by putting them in vats of concentrated sulfuric acid and essentially disintegrating the bodies away. You can look that up. John Haught, I think his name was, Haight. But yeah, so when we use acids in the lab, we're very careful. Especially, I dilute them down for us, but they can still have a stinging effect, especially if you have an open flesh wound. But definitely very disintegrating to metals. If you've ever seen like Orange County choppers, they can put a bike frame or something, dip it into an acid bath so it pits the metal. It disintegrates little pieces of it so that when they chrome plate it, the chrome sticks to the metal frame that much better. Acids are quite commonly consumed. Alright, so lots of acids in our fruits and carbonated beverages. Ascorbic acid you see here, that's another name for vitamin C. Acetic acid being vinegar, carbonic acid in pop, and of course citric acid in citrus fruits. So a lot of acids are quite consumable. So now we're on to the bases. So our base properties here, acids are tart or sour, bases taste bitter or chalky. Not very pleasant tastes. So especially the first antacid tablets used to be very chalky. They've figured out a ways to make them much more palatable now. But we don't really eat a lot of things that are bitter. One example could be if you've ever been tricked by Baker's chocolate, unsweetened chocolate. It looks like a chocolate bar, smells like a chocolate bar. Put it in your mouth, it does not taste like a chocolate bar because there's no sugar in it. So that's always a fun trick to play on little kids. Hey, you want some chocolate? And then they put it in their mouth and can kind of make a face very similar to this little girl's right here. Bases can also be electrolytes, both strong and weak, just like acids. And they also react with indicators, but typically a different way. So bases turn pH paper blue where the acids were red. And this phenolphthalein stuff, when it's in a base, has a nice distinctive pink color. So that's another way we can distinguish whether we are working with an acid or a base. Bases do not react with metals to produce hydrogen gas. The acids did. And whereas acids are corrosive, bases are what we call caustic, which means burning. And so if your skin comes in contact with a strong base, you can get quite a bad caustic burn. And essentially it's like a burn from heat, but it's a chemical burn, and you can see some of the same effects to the skin. Bases are not very consumable. Antacids are about the only thing that we directly consume that are a base. Baking soda, baking powder we can use in cooking, but for the most part bases are much more important to us as cleaning agents, like ammonia or drain cleaner, all different kinds of soaps and detergents. So that's where bases earn their keep. So those are the properties. And again, as I mentioned, they can both be electrolytes, which means they can conduct electricity when they're dissolved in water. And some are good, some are not. And remember, what is the difference? And that's what I have here. The difference is the degree of ionization. That also affects whether or not we have a strong acid or a strong base, or a weak acid or a weak base. And so, as far as strong versus weak is concerned, strong acids and bases have complete ionization, complete breaking down in the water, whereas the weak ones only have partial ionization or dissociation. So we see a list of some strong acids. Hydrochloric, sulfuric, and nitric acids are very strong compared to acetic acid, hydrofluoric acid, and phosphoric acid, which are much weaker. Strong bases, some examples of them: sodium hydroxide, potassium hydroxide, whereas some weak bases, ammonia and sodium bicarbonate, otherwise known as baking soda. Oops, school is over there, that's the bell. But I'm going to stop the video here, and so this will cover the first part of the notes, and then the second part, numbers 3 and 4, I'll finish up in another video.